Every smartphone on the planet broadcasts a constant stream of location data. Satellites map the entire Earth in high resolution every 24 hours. Yet on the night of March 8, 2014, a Boeing 777 carrying 239 people lifted off from Kuala Lumpur and effectively exited the modern world. Official investigations confirmed the aircraft did not suffer a sudden accident. Radar data showed it veered off its assigned route to Beijing, executing a sharp U-turn back over the Malay Peninsula. Following that turn, someone inside the cockpit manually disabled the transponder and the routine data reporting systems, blinding civilian air traffic control. The aircraft then flew in radio silence for over 6 hours, heading steadily into the remote reaches of the southern Indian Ocean. Every piece of evidence suggests the disappearance of MH370 was a successful attempt to remove a massive airliner from global tracking networks. The ensuing search became the most expensive in aviation history, with global governments spending over $155 million on the initial recovery effort. Research vessels like the Investigator deployed robotic submarines to map 400,000 square kilometers of the deep ocean floor, a landscape of volcanic ridges and canyons shrouded in total darkness. Despite these efforts, including a 2026 update from Ocean Infinity mapping an additional 140,000 square kilometers, searchers found no sign of the wreckage in the designated zones. This creates a central problem for the investigation. The ocean floor remains empty, exactly where the mathematical models predicted the plane would be. Investigators originally tracked the plane by analyzing automated electronic handshakes between the aircraft and a communication satellite. These records established a curved boundary line across the southern Indian Ocean, called the Seventh Arc. Authorities assumed the plane flew on autopilot until it ran out of fuel, leading to an uncontrolled dive into the water. That specific assumption of a vertical, unpiloted descent dictated the boundaries of a search that has failed for over a decade. In late 2024, researcher Vincent Lean published a paper directly challenging the official satellite data interpretation. His analysis suggests the signals are more consistent with a controlled eastward glide. This means the plane likely hit the water far from the original search zone. This doubt is supported by a 2024 study from Cardiff University, which utilized deep-sea hydrophones, underwater microphones used to monitor ocean sounds. A heavy aircraft hitting the surface at high speed creates a massive acoustic signature. These hydrophones recorded no such impact sound within the official search area.
These findings suggest the foundational crash theory is the primary reason the subsea search failed, rather than the difficulty of the underwater terrain. Fresh evidence for a new search zone relies on marine biology. In 2015, a wing component called a flaperon washed up on Reunion Island, encrusted with barnacles. As barnacles grow, their shells record the chemical signature of the ocean temperatures they inhabit at each stage of their life. Researchers read these shell layers like tree rings to reconstruct the specific water temperatures the wing drifted through. The chemical data suggests the debris originated from a point on the Seventh Arc, roughly 1,000 miles away from the initial search grid. This biological record is now being used to reverse engineer a drift path, providing a new map for the next phase of the investigation. The disappearance of MH370 forced the aviation industry to adopt real-time, 15-minute global tracking rules to ensure a commercial flight can never vanish again. For the families of the 239 people on board, these scientific developments represent the only remaining hope for an answer. As marine robotics companies propose new searches based on these biological and acoustic models, the quest to locate the aircraft remains a high priority for international investigators. Until the wreckage is located, MH370 remains a haunting reminder of our technological limits when faced with the vast southern Indian Ocean.